My dear students, welcome to IIT JEE NEET classes. This is Ashok, Chemistry faculty. Today I am explaining ionic equilibrium chapter, very important questions which is most useful to your JEE Mains and NEET preparation students. The question is, the first and second ionization constants of H2X are 2.5 into 10 power minus 8 and 1 into 10 power minus 13 respectively. The concentration of X2 minus in 0.1 m H2X solution is dash into 10 power minus 15 m near integer value. The solution is, for a weak diprotic acid, diprotic acid H2X, we have two equilibrium constant value, that is Ka1 and Ka2 values. That is Ka1 value is 2.5 into 10 power minus 8, then Ka2 value is 1 into 10 power minus 13. Based on these values, we know very well Ka1 value is much larger than Ka2 value. So here the ionization steps are: number 1, H2X dissociated into H plus and HX minus, that is Ka1. Then in second step, HX minus converted to H plus and X minus 2, Ka2 value, that is 1 into 10 power minus 30. So here the concentration of H plus ion is primarily determined by first ionization, that is H plus is equal to root Ka1 into C. So that is Ka1 value 2.5 into 10 power minus 8. The concentration of H2X solution is 0.1. So this value is 2.5 into 10 power minus 9. So this we can write nothing but 25 into 10 power minus 10. So from this we find out H plus value is 5 into 10 power minus 5 m. From the first ionization reaction, we find out that H plus and HX minus both values are same. So that is 5 into 10 power minus 5 m. But for the second ionization, that is HX minus converted into H plus plus X minus 2. For the second ionization, Ka2 is called H plus X minus 2 by HX minus. So from this, X minus 2 is called Ka2 into HX minus by H plus. So here Ka2 value we know, and also X minus 2 value we want to find out. HX minus value and H plus value also we know that. So Ka2 value is 1 into 10 power minus 13 and HX minus is 5 into 10 power minus 5 by H plus value also 5 into 10 power minus. So from that, X minus 2 value is 1 into 10 power minus 13 m. So to express this value in the form of X into 10 power minus 15 m, then X value is Ka2 is equal to 1 into 10 power minus 13 m. So in that we can write this 10 power minus 15, that is 100 into 10 power minus 15 m. It is equal to nothing but 10 power minus 13. So X is equal to 100. So the answer is 100. The next question, X milligram of pure HCl was used to make an aqueous solution 25 ml of 0.1 m BaOH2 solution is used when the HCl solution was titrated against it. The numerical value of x is dash into 10 power minus 1 nearest integer. Given molecular mass of HCl and BaOH twice are 36.5 into 171 grams per mole respectively. So in this question, so we find that HCl solution was titrated against BaOH twice solution. So here the reaction exists in between HCl and BaOH twice, barium hydroxide. So the reaction between HCl and BaOH twice is exists like this, that is 2 moles of HCl is react with BaOH twice, it gives barium chloride, then water molecule. So this is the reaction between hydrochloric acid and barium hydroxide. So from this reaction we find out 2 moles of HCl react with 1 mole of BaOH twice, it gives 1 mole of barium chloride and 2 moles of water. We know very well molarity is equal to N by V. From that N is equal to M into V. From that moles of BaOH twice, moles of BaOH twice used in this reaction is N is equal to, what is the molarity? 0.1 into how many? 25 milliliters, that is 0.025 liters. So that N is equal to 0.0025 mole. That is moles of BaOH twice used in this reaction. So here from that based on balanced equation we find out moles of HCl is double the moles of BaOH twice. So moles of HCl used is equal to 2 into 0.0025, that is 0.005 moles. So we know very well mole is equal to mass by molecular weight. So from this mass is equal to mole into molecular weight. So mass of HCl is equal to mole into molecular weight of HCl. So here mole is 0.005 and molecular weight of HCl is 36.5. So from this we know this value is nearly 0.1825 grams. So this only we can write milligrams, 182.5 milligrams. This we can write in the form of x into 10 power minus 1. So that is 1825 into 10 power minus 1. So the value is 1825. X value is 1825. That is 1825 is the answer. The next question is, which of the following mixture gives a buffer solution with pH 9.25 and given pKb of NH4OH is equal to 4.75. So from this pH value we find out pH is equal to 9.75, that is more than 7. That's why this is what type of buffer? Basic buffer solution. This is basic buffer solution. So basic buffer solution pH value has base that is more than 7. pH is greater than 7. Then the buffer solution, basic buffer solution is obtained by mixing weak base and salts of its strong acid. So basic buffer solution is obtained by the mixing of weak base and salts of its strong acid. That is basic buffer solution. From these options given below, we find out which is containing weak base and salts of strong acid after combination of these two. We know very well pH plus POH is equal to 14. Already we have pH value, that is 9.25. Then POH is equal to 14. So from this POH is equal to 14 minus 9.25. That value is nearly 4.75. So we know very well the formula of basic buffer solution. POH is equal to pKb plus log salt by base. Salt by base. So POH value is 4.75. pKb value they given, that is 4.75 plus log salt by base. Salt by base. So we know very well in the preparation of basic buffer solution, millimoles of base is equal to millimoles of salt. Millimoles of salt solution. So how to find this millimoles? Millimoles is equal to molarity into volume of the solution in milliliters. So molarity they given here, volume of the given solution also they given. So from this we know that NH4OH is reacted with HCl. It gives NH4Cl plus H2O. From the option 1 we know that 0.2 m NH4OH is treated with 0.5 liters HCl. So if we take millimoles, molarity into volume. So here NH4OH they given 0.2 mole molarity NH4OH, 0.5 liters of NH4OH treated with 0.1 m HCl and 0.5 liters of HCl. So we convert into millimoles, that is molarity into volume in milliliters, that is 0.2 into 500, that is 100 millimoles. 100 millimoles. Same like that here also, that is 0.1 into 500, that is 50 millimoles. So here 100 millimoles of NH4OH treated with 50 millimoles of HCl. Here HCl is limiting reagent. How much limiting reagent will have? Same amount of product also will form, that is 50 millimoles of HCl is obtained. At the end of the reaction we have still remaining 50 millimoles of NH4OH. So in the preparation of basic buffer solution, it is the combination of weak base plus salts of its strong acid. So that is what? NH4OH plus NH4Cl. After completion of that reaction, still some amount of weak base is exist in that solution. That is basic buffer solution. That's why basic buffer solution pH value is greater than 7 due to the presence of some amount of base. So still after completion of this reaction, we have 50 millimoles of NH4OH is remaining. So from this we know very well millimoles of NH4OH is equal to millimoles of NH4Cl. So millimoles of NH4OH is equal to millimoles of NH4Cl. So that the first option is the correct one. So in the given options, the first option is basic buffer solution. In second option they given 0.2 molarity of NH4OH is treated with 0.4 liters and 0.1 m HCl is treated with 1 liter of HCl. So convert into millimoles, 0.2 into 400 milliliters, that is 80 millimoles. Same like that here, 0.1 into 100, that is 1000 milliliters, that is 100 milliliters, that is 100 millimoles. So in this second option, we have 80 millimoles of NH4OH, 100 millimoles of HCl. So in this what happened? NH4OH total consume. After completion of the formation of NH4Cl, still there is no NH4OH. Actually in the basic buffer solution is what? That is base, weak base and salts of strong acid. Then some amount of base is present. But here 80 millimoles of NH4OH is treated with HCl. Completely it is reacted. Still after completion of that reaction, there is no remaining amount of NH4OH. It is completely consumed by HCl. So it is a wrong option. In third option, 0.4 molarity of NH4OH treated with 1 liter and treated with 0.1 molarity of HCl and 1 liter of HCl. Convert into millimoles, that is 0.4 into 1000 ml, that is 400 millimoles. So here 400 millimoles of NH4OH treated with 100 millimoles of HCl, it gives 100 millimoles of NH4Cl, because HCl is the limiting reagent. So how much is limiting reagent is there? Same amount of product will form. But in this reaction, millimoles of NH4OH is not equal to millimoles of NH4Cl. After completion of this reaction, still we have 300 millimoles of NH4OH. So in this millimoles of NH4OH is not equal to millimoles of NH4Cl. That's why it is not basic buffer solution. So in that fourth option, 0.45 molarity of NH4OH and 0.2 liters of NH4OH is treated with 0.2 molarity and 0.5 liters of HCl. Convert into millimoles, 0.5 into 200 milliliters, that is 100 millimoles of NH4OH, and 0.2 m into 500 milliliters, that is 100 millimoles of HCl. So here 100 millimoles of NH4OH treated with 100 millimoles of HCl, it gives 100 millimoles of NH4Cl. So here total NH4OH is consumed. So still there is no millimoles of NH4OH remaining. Actually basic buffer solution means what? Base, weak base and salts of strong acid. Still some amount of weak base is present. Then that is pH value is greater than 7. So then it is equal to pH is got 9.25. But here after completion of that reaction, there is no remaining amount of NH4OH solution. So it will be completely reactive with HCl, form 100 millimoles of NH4Cl. So that it is also not a basic buffer solution. So the correct option is option 1. The next question is, consider a weak base B of pKb value 5.699 x milliliter of 0.02 m HCl and y milliliter of 0.02 m weak base B are mixed to make 100 ml of a buffer of pH 9 at 25 degrees centigrade. The value of x and y respectively are given. Log 2 value they given, log 3 value they given, log 5 value they given. So from this reaction we find out. So here strong acid and weak base is mixed. That is nothing but basic buffer solution. So here buffer pH value they given 9. pH value 9 means pH plus pOH is equal to 14. From that pOH is equal to 14 minus 9, that is 5. So this is basic buffer solution. So that basic buffer solution formula, pOH is equal, for basic buffer solution, pOH is equal to pKb plus log salt concentration by base concentration. So here the reaction between strong acid and weak base, we can get BH plus Cl minus. This is the reaction between weak base and strong acid. So from the reaction they given 0.02 molarity of HCl and X milliliters is treated with 0.02 molarity of weak base of Y milliliters. So in that millimoles, 0.02 into X millimoles. Similarly here 0.02 into Y millimoles of base is treated. So 0.02 X millimoles of HCl treated with 0.02 millimoles of 0.02 Y millimoles of weak base. So HCl completely consumed in this reaction. So we can get 0.02 X millimoles of acid salt. So here 0.02 X millimoles of strong acid completely react with 0.02 Y millimoles of weak base gives 0.02 X millimoles of salt. So we know very well. So here POH is called pKb plus log salt by base. So POH they given that is 5. Okay na? This they given 5.699 plus log salt by base. From that log salt by base is equal, okay na, 5 minus 5.699, that is minus 0.699. So if you remove that log, salt by base is equal anti-log 0.699. So that salt by base, so this value is 5, that is 5, log 5 0.699, that is 1 by 5. So here 0.02x millimoles, 0.02y millimoles. So after that it is completely react with 0.02y minus 0.02x. It gives how much? 0.02x millimoles. This is salt. So that salt means x by base means y minus x. Y minus x is equal to 1 by 5. From that 5x is equal to y minus x. From that y is equal to 6x. So from that question we know that weak base and strong acid both are mixed to form 100 milliliters of the solution. So weak base and strong acid both. So here weak base is x, strong acid is y, is equal to 100. So we know that y is equal to 6x. X plus 6x is equal to 100. That is 7x is equal to 100. X is equal to 100 by 7. So x value is nearly 14.2. 8. Nothing but 14.3. That is x value. Then y value is equal to 6x. 6 into x is how much? 100 by 7. 100 by 7. Nothing but y is equal to 600 by 7. So 600 by 7, the value is 85.7. So that x value is 14.3, y value is 85.7. So here X value is 14.3, Y value is 85.7. So second option is the correct one. The next question is, consider the dissociation equilibrium of the following weak acid, that is HA dissociated into H plus A minus. If the pKa of the acid is 4, then find out the pH of 10 millimoles of HA solution is, that is millimolarity of HA of solution is, that is nearest integer value. In that the given the degree of dissociation can be neglected with respect to unity. So here the given weak acid, that is HA, it will be dissociated into H plus A minus. So pKa of the acid they given, that is 4. From that Ka is equal to 10 power minus 4. So here they given 10 millimolarity of HA solution. Here 10 milli means 10 power minus 3 into that is molarity of HA weak acid. So that this is what 10 power minus 2 molarity of HA, that is nothing but 0.01 molarity of weak acid. So here they given the degree of dissociation can be neglected. So the concentration of HA is, that is 0.01 m. So the concentration of HA remains approximately how much? That is 0.01 m. So from this we find that Ka is equal to, so here this is both are same, that's why H plus is equal to A minus, that's why H plus square we can write by HA, because H plus concentration is equal to A minus concentration. So here Ka is equal to H plus whole square by HA. So in that Ka they given, that is 10 power minus 4 H plus, that is HA value, that is 0.01. From that H plus whole square is equal to 10 power minus 4, this is nothing but 10 power minus 2. So this total value is 10 power minus 6. From that H plus is equal to root 10 power minus 6, that is 10 power minus 3. So pH is equal to minus log H plus, so that minus log 10 power minus 3, that is minus into minus plus 3 log 10 1, so that pH value is 3. So the answer is 3. So the pH of 10 millimolarity of weak acid HCl solution is 3. The next question is the molar solubility of zirconium phosphate with molecular formula Zr4 plus thrice PO4 minus 3 4 times, that is Zr3 PO4 4 times is given by the relation. So that is zirconium phosphate, it will be dissociated into 3 moles of zirconium ion and 4 moles of phosphate ions. So here solubility is 3s and here 4s. So from that KSP is equal to 3s whole power cube then 4s whole power 4. So this is 27 s cube 256 s power 4. So this value is nearly 6912 s power 7, that is KSP. So s power 7 is equal to KSP by 6912. From that, S is equal to KSP by 6912 whole power 1 by 7. So the correct answer is second option. So the next question is KSP for chromium hydroxide, that is 1.6 into 10 power minus 30. What is the molar solubility of this salt in water? The molar solubility, yes, they are asking. So we know very well chromium hydroxide, it will be dissociated into Cr plus 3 plus 3OH minus aqueous solution. So the solubility of these ions is, this is S, this is 3S. So from that, KSP is equal to S whole power 1 mole, that is 3S whole power 3 moles, that is. So from that, KSP is equal to 27 S power 4. So S power 4 is equal to KSP by 27. That is S power 4 is equal to KSP they given 1.6 into 10 power minus 30 by 27. Then from this, S is equal to 1.6 into 10 power minus 30 by 27 whole power 1 by 4. Otherwise, fourth root 1.6 into 10 power minus 30 by 27. So the correct option is 1.6 into 10 power minus 30 by 27. That is fourth root. So option 3 is the correct answer. So dear students, remaining questions later I explain. So dear students, please subscribe my YouTube channel and click on bell icon for daily JEE and NEET updates. Thank you very much.